Okay, so it says you can use the following formula to find the balance of an account that earns compound interest. So A is the balance, P is the principal or the initial deposit, the annual interest rate, R, and it should be expressed as a decimal, N is the number of times the interest is compounded per year, and T is the time in years. Okay, so let's take a look at problem 2 with compound interest. It says, suppose that when your friend was born, your friend's parents deposited $2,000 in an account paying 4.5 interest compounded quarterly. What will the account balance be after 18 years? So we want to see if this is actually a good investment, right? So we're going to use the formula that they gave us, same formula. And we know that the initial amount, which is P, is 2,000. The rate, which is 0.45, we change that to a decimal, which is going to be 0.045. Quarterly means 4, so my N is 4. And I put an 4 for N here as well. And then for T, my time in years is 18. All right. So when I evaluate this, 1 plus 0.045 divided by 4 is 1.01125, and 4 times 18 is to the 7 is 72. So I'm going to raise this to the 72nd power, and then whatever I get, I'm multiply by 2,000, and I see that the balance would be 4,475.53 after 18 years. Not a bad amount when you don't have to do anything. It's working for you. All right, so it says, suppose the account in problem 2 pays interest compounded monthly. What will the account balance be after 18 years? So let's check it out. Okay, so we'll use the same formula. Oops. A equals principal times 1 plus rate over N times NT. Okay, and so same thing. Our principal, our initial amount is $2,000. Our rate was 0.045. And this time it's compounded monthly. So I'm going to divide by 12 instead. And so my N is going to be 12, and my time is still 18 years. Okay? So let's put this in our calculator. Oops. All right. So we'll first do 0.045 divided by 12 plus 1 is going to give me 1.0035. So we'll come here. A is equal to 2,000 times 1.00375, and then we have 12 times 18. I haven't done that calculation yet. All right, so I went ahead and multiplied that. 18 times 12 is 216, so we'll put that on our board. So we get area equals 2,000 times 1.00375 times 216. So now let's put that in our calculator. We get 1.00375 raised to the 216 power. I get 2.245. So we get A is equal to 2,000 times 2.245. Okay, we'll multiply that times 2,000, and I get 4,489. Not much of a difference if you notice. So 4,889 and 1 cent. 4,489 and 1 cent. Okay, so it looks like almost $14 more, a little bit less than $14. I hope this helps.